Post independence, our great visionary leaders, Pandit Jawaharlal Nehru ji, the first Prime Minister of India, and Shri Keshav Dutt Malviya ji, the father of the oil industry, identified crude oil or petroleum as one of the most important sectors for the growth of the country and for providing the energy requirement for its teeming masses. Crude oil, as we all know, needs to be processed in a series of steps, including separation as well as conversion processes, ultimately to produce products that we all use such as LPG, petrol, kerosene, diesel, as well as petrochemicals such as polyethylene, polypropylene, aromatics, etc. These products have to be eco-friendly and clean. In other words, when we burn or use them, it should have minimum impact on the environment. Not only that, when the crude oil is processed to the ultimate products, the environmental impact on such processing should also be minimum. The Indian Institute of Petroleum has identified, developed and commercialized technologies which actually meet these objectives and have helped the industry to meet the environmental protection that is required to keep the air clean.
IIP, an ISO 9001-2008 certified institute, is devoted to multidisciplinary areas of R&D in the downstream sector of hydrocarbon and related industries. The institute is an internationally renowned R&D organization providing quality research and innovative technologies for the national and international marketplace. IIP is conducting research in various areas. Crude Evaluation Lab analyzes the hydrocarbon feed samples from petroleum refineries. It also supports BIS for making test methods and specification of petroleum products. The lab is well equipped with various test facilities: true boiling point distillation, micro distillation, auto flash point, atmospheric distillation, XRF sulfur analyzer, automatic density meter, vacuum distillation, total sulfur analyzer, automatic freezing point and total nitrogen analyzer. Reforming is a process where the low-value hydrocarbon molecules are transformed into high-value hydrocarbon products in presence of a specific catalyst material. IIP has developed an indigenous catalyst, that is IPR 2001, which is successfully running in Chennai Petroleum Corporation Limited. IIP has also developed catalyst for continuous catalytic reforming technology. Process for extraction of aromatics from reformed naphtha was developed at IIP. This indigenously developed process for extraction of benzene and toluene was commercialized in 1985 at BPCL Mumbai. This was the first largest commercial unit based on indigenously developed technology. IIP also developed another process for production of food-grade hexane containing less than 1% aromatics using sulfolane as solvent, which was commercialized at BPCL Mumbai in February 1989 and also at CPCL Chennai in 1992. Using this technology, sufficient food-grade hexane is being produced in India, which helped to stop the import of this vital product used in vegetable oil industry. More efficient extraction process for de-aromatization of raw hexane using N-methylpyrrolidone as solvent was developed. A grassroots unit has been commissioned at HPCL in November 1997, where food-grade hexane produced contains lower than 0.05% of benzene.
As you would have seen, the Indian Institute of Petroleum has the capability to provide an end-to-end solution to state-of-the-art technologies, products, know-how and services. How do we make it happen? We discuss with the industry, identify their needs, form teams which consists of chemists, scientists, engineers and environmentalists, and then we develop such know-how, discuss with the clients and commercialize them.
IIP has collaboration with a Norwegian research institute, SINTEF, under Indo-Norwegian Cooperation Program for developing novel absorption-based technology for sulfur removal from transportation fuel. The process developed and tested requires substantially lower amounts of hydrogen compared to conventional sulfur reduction technology. It is now acknowledged that global warming arising from rising levels of CO2 in the atmosphere is causing climatic changes and is one of the biggest environment threats today. IIP has developed an indigenous technology. This technology is based on vacuum swing absorption and uses special materials to trap the CO2 in the flue gases. This trapped CO2 is then recovered from the absorbent in high purity suitable for sequestration. The laboratory data will be used to design a pilot plant that will be put up at power plant for CO2 recovery. Advanced Cracking Evaluation Unit is used for evaluating FCC catalysts. This unit is a fluidized bed reactor and is improvised microactivity test unit. It generates data which is several times more precise than fixed bed mat unit. It employs cyclic operation of a single reactor containing a batch of fluidized catalyst. The catalyst experiences the same reaction and temperature as does the catalyst material circulating in refinery FCC unit. Broad area of activities of this group are lube extraction, solvent dewaxing, deoiling. Processes available for NMP-based refining technology for simulations production of quality lube oil-based stocks, advanced carbon materials, and high BMCI extract. Dipolymeric dewaxing aid additive to enhance slurry filterability during LOBS production through solvent dewaxing. Upgrading fuel oil components into premium refinery products. Processing of used lube oils. IIP has carried out extensive studies to improve the low temperature flow behavior of various crude oils using commercial as well as IIP developed additives. The Wax Rheology Lab is equipped to measure the rheological properties, morphology of wax crystals, wax deposition, wax appearance temperature, pour point, etc. and carry out rheology studies on all types of crude oils, evaluation of pour point depressant, additives, etc. IIP has carried out laboratory scale studies to convert waste plastics into value-added products and has developed a simple catalytic process by which exclusively any one of the products, gasoline or diesel or aromatics, along with LPG can be produced in the same experimental setup. IIP developed technology for making polymer-modified bitumen. Based on the developed technology, IIP constructed a test road of 1 km state highway. Presently, IIP is working on making bitumen at lower cost to reduce cost involved in the construction and repairing works of roads and highways, including polymer mixed with waste plastic. IIP developed a know-how for Visbreaker process. It has revamped Visbreakers in different refineries to soaker mode successfully, and grassroots soaker Visbreakers were also set up at Panipat and HPCL Vishak. The Advanced Gas Separation Lab has been engaged in development of gas separation process based on absorption in liquids for toxic gases like hydrogen sulfide, sulfur dioxide and carbon dioxide from power plants, refineries and chemical industry. Technologies have been developed for removal of hydrogen sulfide and sulfur dioxide from flue gases and are ready for commercialization. The GC lab is equipped with various state-of-the-art equipment to analyze hydrocarbon liquid and gases, biofuels, waxes, etc. Benzene Analyzer is used for the study of benzene, toluene, xylenes present in the engine exhaust gases. Inductively coupled plasma atomic emission spectrometer is a multi-element measurement technique, sequential as well as simultaneous, plasma as a source for the measurement of metals, non-metals in petroleum and related products up to ppb level concentration. This technique can measure more than 70 elements of the periodic table. A solar M6 dual Zeeman atomic absorption spectrometer is a sequential technique for the measurement of metals in petroleum and related materials. The equipment minimizes the analysis time significantly. IIP has installed a highly sophisticated, high-resolution FTIR spectrometer with dual source, dual beam splitter and dual detector system to enable measurement in wide spectral range from 27,000 to 350 cm1, that is, mid-IR and part visible range of spectrum. An automatic polarizer fitted in main spectrometer facilitates study of molecular orientations in samples. The aim of catalyst characterization is to obtain physico-chemical data of catalysts using various instruments and to correlate this data with catalyst activity and selectivity to understand the catalyst performance. Microcalorimetry is used for determining the acidity and acid strength distribution of solid acid catalyst using ammonia as a gas phase probe molecule. It's used for measurement of surface area, pore size distribution, total pore volume and average pore diameter of solid porous materials or catalysts. The pulse chemisoptions is used to study the chemisoptions behavior of catalyst surface or metal dispersed on it. Molecular designing of VPO with desirable structure and composition is a thrust area in order to achieve the high efficient and selective catalyst for the functionalization of hydrocarbon. Specialty Product Group works on the utilization of non-edible vegetable oils for the production of additives, lubricating oils and many other value-added products. Non-edible vegetable oil-based technologies for biodegradable lubricants such as 2T oils, metal working fluids, soluble cutting oils, insulating oil, gear oil, hydraulic oil, lithium greases, solvent, degreaser, heating oil, etc. have been developed. Additives have been developed for high-pore crude oil and low-sulfur containing lubricating oil, PP, CP and CFPP additive for low-sulfur containing diesel fuel. Development of wax crystal modifier additive which is used as dewaxing, deoiling additive for lube base oil production has been done. The additive is being used regularly by several lube refineries in the country. IIP has on board emission measurement system, which is the first such equipment of its kind in India for exhaust emission measurement under actual running of the vehicle on road. This system is mounted directly on the vehicle for continuous measurement of CO, CO2, HC and NOx. It also provides mass emission data in grams per kilometer and fuel consumption. IIP is one of the certifying test agencies for mass emission certification of the new vehicles. The vehicle is mounted on a chassis dynamometer on which road conditions can be simulated in the form of a driving cycle consisting of constant speed, acceleration, deceleration, etc. as in the field. The Tribology laboratory is well equipped with various test facilities which meet a large number of national and international standard specifications in the area of industrial lubricants and greases, apart from other advanced R&D equipment and surface analytical tools, including some exciting work on nanotechnology. The institute deals with R&D work in the area of efficient utilization of fuels in industrial, domestic and rural sector and development of fuel-efficient design of combustion appliances using petroleum and for welfare of rural masses in sugarcane belt areas. Design of gur bhattis has been improved and popularized. Due to proper combustion inside the furnace, these gur bhattis can save biomass fuel, bagases up to 10% and there is reduction in chimney smoke.
One of the areas that we have identified in the last 15 years is to be able to move away from crude oil or fossil fuels as it is known, to be able to use renewables, to harness them to make commercial energy. In fact, you will be happy to know that when crude oil prices were still low, even in mid 90s, we had active programs in converting non-edible vegetable oils to biodiesel, lubricants and additives. As we move into the 21st century, now we know that how important these commercial energy forms are. In fact, a new term has been coined known as sustainable energy. Sustainable energy is energy which is economic, abundantly available, has minimum carbon footprint as well as it is easy to use. I think the last term is most important. When we talk about fuel, there is always a constant fight between fuel and food, but I believe as long as the human being would need food, it will grow food, and with that we will have plenty of waste biomass, and waste biomass, if can be converted and usable commercial energy, it can really help the country to reduce the crude intake, which is extremely expensive in terms of foreign exchange outflow. One form of sustainable energy is based on bioresources. Bioresources could be in terms of converting that to ethanol, or it could be in terms of converting non-edible vegetable oil to biodiesel, or to convert waste biomass to commercial energy. The Indian Institute of Petroleum is working on all the three aspects in a very holistic way. We have a very active program to create second generation biofuels by converting lignocellulosic biomass to ethanol using thermophilic yeast, which we have gathered from the upper reaches of Himalayas. On the other hand, as far as biodiesel is concerned, we have a unique heterogeneous catalyst which can convert non-edible vegetable oil as well as high free fatty acid oils to biodiesel. Biomass conversion to commercial energy involves a complicated series of steps, which includes fast pyrolysis of biomass followed by upgradation of the bio oil to transportation fuels like gasoline and diesel. All of this has to be looked at from ultimately their impact on the environment, so that when we do this, the overall impact